on. Oh, and look at that. We already have 2 people on YouTube. That's fantastic. Okay, let's see. So I think we have just a few people on Discord and just a small handful of people on YouTube. So we'll just hang out for a little while longer and wait for a few more people to waltz on in. He's probably sleeping. That's okay. Yeah, because I've got a couple announcements that I'd like to make sure everyone hears about. I'll be making some announcements on my website and on the Google Classroom just regarding the project. And there's been some changes as of today. So yeah, a lot of changes actually. Okay, how are you guys doing outside of school though? You guys are you able to go outside, go for bike rides or anything? You guys doing anything fun? I know, the weather's just so nice. Yeah, yeah. There's a park across the street from my apartment, and my wife and I have been having picnics there, and then just the other day I just like laid down on the grass and just like looked up at the sky, and it just seemed like so refreshing. Just I spent so much time inside. Like the weather's been so terrible, right? So I mean, on top of the pandemic, there's also just like this notion of it being bad weather, so who wants to go outside? So it's so nice to be outside, to have a nice breeze in your face, and yeah, it's great. Okay, so there's still just a couple people on YouTube. Okay, I may as well just talk about the announcement now. I mean, I'll make it very obvious that there's been some changes on Google Classroom and on my website as well. Do you guys how often do you guys use my website? Is it mostly because I post everything on Google Classroom now anyways? So do you I'm not going to take it the wrong way. I just genuinely want to know, do you think most students are still using my website or what? What do you think? Oh yeah, because the exit slip is through my website. I didn't think of that. Yeah. So okay, so that means that anyone who's using my exit slips will see my website. And I made a big update banner yesterday. So when you go to the website, there's a big update. But turns out I have to make another update. So that's kind of the annoying thing about when plans change, is that you turn into this person who becomes very annoying, right? It's like, oh no, another update. I have to stop what you're doing. Stop it, change it again. So yeah, I'm going to be that annoying person today and have another update. So I guess I'm going to have to think of a way to make an announcement saying that there's been an update, but it's different than the update that I gave you yesterday. So if you have any ideas, let me know. Okay, so yeah, I'll just cut to the chase. So yesterday I told you that the final exam has been canceled, right? That there's no longer the option to do the final exam for the final assessment. I told everyone, okay, so we're going to do the final project instead. Everyone is going to do the project. So you no longer have that as an option. So I told everyone, yeah, you're going to do the project, and that's what the announcement is on the website and on Google Classroom. So I learned right at the very end of the day yesterday that not only are the final exams canceled, but there can no longer be any final assessments at all. So effectively saying, so the project is canceled too. So I feel like we've kind of invested a lot into this project already. So I I talked to a few more people, and so what we're gonna do is I'm gonna turn the final project. I'm gonna change it from being like this big thing that is like a final assessment, and I'm gonna turn it into something smaller that is just will take place of an assignment. So it will not be a final assessment. It is going to just be an assignment that we do near the end of the year. So the main difference, well, there's two things that are different. There's two big differences between what it was and what it is now. First difference is the size of it. It's going to just be much smaller. So it's something that you can probably do in much less time. And the other difference is that it is no longer worth a substantial portion of your mark. I think that it was intended to be 30% of your grade. It is no longer worth 30% of your grade. It's just, it'll be worth something like 10% of your grade, right? I'll just be taking averages of all of the assignments that we've done and things like that. So it can no longer be 30% of your grade. So that's how that's going to work. So the gist of it, I mean, the way I'm going to turn it into like from a big project into something a little bit smaller is to just, instead of doing 4 topics, I think what we'll do is we'll do 2 topics. Okay, so we're going to narrow it down. We're going to just do 2 topics. It'll still be the same due date, so it'll still be, you know, due the Friday, that, or like our last Friday, or I guess our second last Friday. What did I say? The 12th, I think. 12th of June. Yeah, 12th of June. So we'll still be due on the 12th of June, but we'll just think of it more of as an assignment than a final assessment. So it's not going to be worth the same amount. It won't have the same weight. However, it will be a little bit smaller as well in terms of how long I would expect that it would take you to complete this assignment. So yeah, that's the main difference. Is we're just going to turn it into an assignment. Okay, so yeah, I'm sorry to keep changing the plan and changing it again and changing it. But just this information is constantly being updated, and yeah, so I'm learning this pretty much at the same time that you are. So yeah, again, sorry about that. I hope that you're able to sort of stay on top of all of these changes and adjust accordingly. So that's the major difference, and I'll make a more clear and easy to understand version of this on my website and on Google Classroom, so you can really get to the bottom of it. So if you have any questions, now would be a good time to ask. You can either just say something in Discord or make a YouTube comment or chat text or whatever you want to call it. Otherwise, I'll just keep on going with the class. Yeah, so that's how that's going to work. Okay, so no questions then. We're good on that. Okay, cool. And if you think of a question or something, just don't hesitate just to shout it out. Okay, so what we're going to talk about today is this little thing called the ambiguous case. So I kind of hinted at it a little bit yesterday. So there's this idea called the ambiguous case, and it's kind of this thing that comes up when we have a specific type of triangle. So let's see here. Just going to go back here. Okay, yeah. So the ambiguous case, it happens when we're trying to use the Sine Law. Okay, so let's talk about the ambiguous case. Okay, so this happens when we're using the Sine Law. So when we use the Sine Law, okay, and it happens when we know an angle and 2 adjacent sides as shown. Okay, so here would be this triangle that we are trying to determine some of the lengths of the sides. And we would know this angle, we would know this side, and we know this side. Okay? So the way you can remember this, and be prepared, I'm going to say something crude and a little bit inappropriate, but you can think of this as, well, we start off with this angle here, then we know this side, and then we know this side. So the way you can remember this is with this great little acronym, right? So you know an angle and two adjacent sides. Some people call this the donkey theorem. I don't know why they would call it the donkey theorem, but apparently that's what some people call it. So here's the issue. Here's the issue. So let's say that I know the angle of a triangle, right? Okay, so here's one of the angles. Okay, here's one of the angles. So here's the angle that I know. Okay, and I know a couple of other things about the triangle. I know the length of this side. Okay, right? I'm told that. So if I know this side length, and I know this side length, okay, but I don't know anything else about the triangle. So like, let's say, okay, so the blue means I know, and pink means I don't know. Okay, so everything in blue here I know, but everything in pink I don't know. So I do not know the length of this side right here. I don't know how long it is, right? I also don't know this angle, and I don't know this angle. So let's think about that for a second. Let's think about that for a second. So let's say I know that, okay. Let's say I know that this angle right here is, let's say it's 30 degrees. Okay, let's say it's 30 degrees. And oops. So here's my 30-degree angle. I also know the length of this is, like, let's say it's 10 meters. Okay, but I don't know what this length is. And I do know that this is, I don't know, let's say it's 8 meters. 8 meters, okay? But the thing is, we don't know this angle, right? I don't know what that angle is, okay? So in this case, like, if we're just told this information, like, how do I know that the angle isn't like this, or like this, or like this, right? It's almost like you can kind of like swing, you can swing this side around until it fits, right? So here's the issue, okay? So I could have like, if I know the angle and two sides, if I can know the angle and two sides of a triangle, occasionally what happens is you can get two triangles that satisfy that angle and the two sides. So sometimes it might actually look something like this. So let's say I know this angle here, and I know this side here, like this. Okay. So because I only, like, the only things that I know are these pink lines. Let's make them pink now. So if I know all the pink stuff, but all the yellow stuff I don't know, well, this triangle is would have the same angle side and side as this triangle over here. So check this out. So I've got that same angle here, okay, and I guess I'll turn this into yellow because I don't know this, because remember, I don't know what the length of this side is, right? So I don't actually know how long this is. Remember, there's no talk about the angle right here, right? This angle we don't know, right? So this angle is unknown, but this side length over here, that looks about to be the same side length as this, right? So like, maybe let's say that this is I don't know, 5 meters, and let's say that this is maybe 6 meters, right? This could still be 6 meters, this still could be 5 meters, we could say that this is maybe, I don't know, 30 degrees, and maybe that one is 30 degrees as well, right? Now all of a sudden, I've got a completely different triangle that has the same angle and two sides as the other one. And that's what the ambiguous case is, okay? So just in the interest of time, I kind of told you that we're doing sort of a fast forward version of trigonometry. I'm gonna just leave it at that for the ambiguous case. I'm just gonna just show you what it is, but in order to truly like deeply understand it, we need to spend more like a week on this stuff, and we just don't have that time. We don't have time to cover the ambiguous case in all of its entirety. But the gist of it is that if you know the angle and two sides, you would think that using the law of the law of sines, that like you'd be able to solve for this side. So can I solve for this? Well, using the law of sines, you could say, okay, well, sine of this angle over this side, right, would be equal to this angle over this, or this angle over this, right? So you should be able to solve for this, but the thing is, you can't always solve for it. So there's certain conditions that you have to check on the ambiguous case. But since this topic isn't really explored a whole lot in grade 12, I'm just going to sort of sweep it under the rug. I mean, with this whole COVID thing, like a lot of topics are being swept under the rug in a lot of classes. And in this class, we haven't actually swept a lot under the rug. We've swept just a little bit, this being part of the stuff that we've been sort of ignoring. But I feel like of all topics to kind of maybe not cover super thoroughly, I think that this is a good topic to just say, yeah, this is what the ambiguous case is. You know, that's what it is. I'm not gonna put an assignment question on this or anything like that. I would just like you to have a kind of a general idea of what it is and of what it looks like. So that's what the ambiguous case is. You can read more about it in your textbook if you like, but I'm not going to cover it super thoroughly. So let's do a few questions on the law of sines, and then if we have time, then we'll start talking about the law of cosines, and then we'll be done with trigonometry. So I mean, that's kind of crazy to do all of trigonometry in like less than a week. Like that's kind of unheard of, but desperate times call for desperate measures, right? So let's do this question right here. So okay, let's see here. Okay, so in this case, I want to solve for all missing sides and angles. Okay, all missing sides and angles of this guy right here. So this one is from your textbook. I will tell you which page it's on if you want to follow along. This is page 108. It's part of your homework, actually, that I'm going to assign. And this is 2A. Okay. All right, so let's see here. I've got, well, this is 88 degrees here. 88 degrees there. This is 35 degrees over here. And this is 44 millimeters. Okay. So I've got two angles and a side, and I should be able to use the sine law to calculate this. So the sine law, remember, is sine of A over A is equal to sine of B over B, which is equal to sine of C over C. So let's go ahead with that. I'm going to start naming some of these things. I'm going to call this one B, this one is A, and this one is C. So let's talk about sine of A over A. So sine of A over A. So that would help us solve for this missing side right here. Okay. And then I also know sine of B over B. I know both of those variables. So why don't I use I'm going to use this equation right here. Sine of A over A is equal to sine of B over B. So sine of A is, well, this is lowercase a here. This is lowercase c, and this is lowercase b. So sine of a over a is equal to sine of b over b. That's the equation that we're going to use. A is 35 degrees, so I've got sine of 35 degrees over a. That's the variable we're going to solve for. That's equal to sine of b, so sine of 88 degrees. 88 degrees over 44. Okay, and now it's just calculator work. So I'm going to do that trick that I showed you yesterday. Okay, so the trick, I'm going to flip the whole thing upside down. So I'm going to say that a over sine of 35 degrees is equal to 44 over sine of 88 degrees. Nice little trick. And let's finish off. So I know that a is going to be equal to sine of 35 degrees times 44 all over sine of 88 degrees. And let's go ahead with that. So I've got 44 times sine of 35 divided by sine of 88. And that's equal to 25.252 or 3. Okay, so and that's millimeters. So I've solved for one side. So A is equal to 25.253 millimeters. Awesome. Okay, so now all we have to do is solve for C, either lowercase c or capital C. Let's start off by figuring what the angle capital C is equal to. So that's going to be 180. So I'm kind of running out of room here. But C is equal to 180 degrees minus 35 minus 88. And that's because the sum of all of the angles must be 180. So I'll subtract the other two angles from 180 to figure out the number that it takes to sum these to 180. So 180 minus 35 minus 88 is equal to 57. So this is 57 degrees here. So I'll just include that now. This is 57 degrees. And now I can use the sine law one more time to, punch this one in. So I'm going to say that, so I'm going to use this portion of the equation. Sine of b over b is equal to sine of c over c. And I'm going to flip that upside down as well. So let's try that out. So I've got that sine of 88 over 44 is equal to sine of 57 degrees over, is my head blocking that off? No, we're good. It's 57 over c, and that's the one that we're looking for. Flip them upside down. So I will get that c is equal to sine of 57 degrees, and that's equal to 44 over sine of 88 degrees. And so that means that c is equal to sine of 57 degrees times 44 over sine of 88 degrees. So let's try that one out. So I've got 44 times sine of 57 divided by sine of 88. And that's equal to 36.923 equals 36.92, actually 924 millimeters. Okay, so we've solved it. We figured out the two missing sides. So let me quickly write that. What was that? 36.293 millimeters. We figured out the two missing sides. We got A and C, right? So A we figured out was 25.253. C was 36.293 millimeters. And then I think that the easiest thing to calculate was this side. We just had to remember the sum of all angles in a triangle is always going to be 180 degrees. So we just took 180, subtracted these two, right? And then once we did that, it was just using the sine law to complete this. Okay, I'm gonna get you guys to try one now. So get out your pencils and paper if you don't have it already. I want you to try part B of the same question. So I've got these guys right here. Looks something like this. Okay. So this right here, this angle right here, side on vertex C, this angle is 118 degrees. This angle right here is 52 degrees. 52 degrees. And this side right here is 45 meters. And this side is B. This side is, or this, not side, this vertex is B. Okay, so I'm going to get you to, I'm going to start off by asking you to solve for lowercase c. Okay? Solve for lowercase c. All right? I'm going to give you 3 minutes for that, and then we'll see how you did. Oops. No, I want to do this. There we go. Okay, so solving for C, what did I say, 2 minutes? Let's do 2.5 minutes. Okay, 2.5 minutes, solve for C, go. All right, time's up, folks. Let's solve this one together. So we're looking to solve for C, which is this side right here. So we're going to use this angle, right? So I've got this angle. So we're going to use sine of this angle over this side, and we need to look for another pair of values who were given like the opposites of. So like the opposite of this angle is this side. So we're, and I know both of those, so that's what I'm going to use. So I'm going to use the equation sine of A over A is equal to sine of C over C. Okay, so sine of A over A, well, that's sine of, oh, and what I'll do is yeah, okay, so we'll start off by writing, so the sine of A is sine of 52 degrees over 45 meters equals, well, sine of C, I know sine of C, so sine of C is 118 degrees over the side that we're looking for. So now what I'm going to do is I'm going to flip the whole equation upside down, and I get that 45 over sine of 52, sine of 52 degrees is equal to C over sine of 118 degrees. And then it turns out that C is equal to 45 times sine of 118 degrees all over sine of 52 degrees. So let's go ahead and punch that into the old calculator and see what it gives us. So I've got 45 times sine of 118 divided by sine of 52, and that's equal to about 50. C is equal to 50.421 meters. There you have it. So that one wasn't too bad. So this is 50.421. Okay. Now I'm going to get you to do the next part of this question, and we'll do that in green. So I'll get you to solve for lowercase b now. So I'm going to give you 2 minutes for this one. Come on, 2 minutes. There you go. 2 minutes. Solve for b. Go. Okie doke. Okay, let's solve this one. I mean, we're just using the same formula again, right? It's kind of not the hardest formula to apply, right? So I'm looking for opposite sides that can help me out here. So I can use those ones, and I'm looking for b, which is this over this. And look at that, we actually still need some more information. So I need to figure out what this angle is. And that I can do by calculating 180 minus 52 degrees minus 118 degrees. And we'll see what we get. Looks like it's going to be a pretty small angle. So 180, minus 180 minus 52 minus 118 equals 10. So it's just a teeny tiny angle. So this is, equals 10 degrees. Okay, so angle B is 10. So that means that sine of 10 over B is equal to sine of well, let's use the a's here. So let's do sine of 52 over 45, sine of 52 over 45. Okay, I'm gonna flip everything upside down, right? Okay, and this is b over sine of 10 degrees is equal to 45 over sine of 52 degrees, and b is now equal to 45 times sine of 10 degrees all over sine of 52 degrees. Okay, almost done. Okay, 45 times sine of 10 degrees divided by sine of 52 degrees is equal to 9.916. And what are we dealing with? Meters. And we're done. So this side here is 9.916 meters. And there you have it, folks. We are done. So I'm gonna leave it there. I don't think we have quite enough time to jump into the cosine law today. So for your homework this weekend, here's what I'll suggest that you do. So homework, I want you to do the following questions on page 108 to 110. So I'd like you to do question 1, all, question 3, all, and I'd like you to do number 10, and also number 16. Okay, so yeah, that's your homework for the weekend. Just a few questions just to get you in the hang of this, and yeah, so stay tuned for an update on the project. You can also expect a new assignment coming up, as well as your assignment to be marked. I know that it's been a tremendously long time since you handed your assignment in, and I'm sorry it's taken me so long to mark it. There's just been a lot going on the past week or two, so my goal is to have that all marked and have a new assignment ready by the end of the weekend. So hopefully that will work out. In any case, I will talk to you guys on Monday, and until then, have a good weekend and take care. Bye bye. Okay.